Bismillahirrahmanirrahim. Assalamu alaikum. I hope everybody is fit and fine and life is treating you well. Let's start our video. In this tutorial, we'll be doing question number 3 of exercise 1.1 from chapter number 1, which is quadratic equation. So we'll be solving the equations, and the method given to us is the completing square method. We'll be doing each step of working so that it will be easy for you to understand this method. Let's solve first part, question number 3. In the very first part, you see the equation is in standard form, 7x squared plus 2x minus 1 equals 0. Now, the very first step of working for completing square method is that the coefficient of x squared should be 1. Here the coefficient of x squared is 7. It has to be 1. So, for making it 1, we'll divide the whole equation by 7. So, 7x squared divided by 7 plus 2x by 7 minus 1 by 7 and let's say 0 divided by 7. So for making the coefficient of x squared as 1, we have to divide the whole equation by 7. So we'll get x squared 2 by 7x minus 1 by 7 and 0 divided by anything is 0. So I hope you have learned the first step of working, that we have to make the coefficient of x squared as 1. Now the second step of work, this is the, let's say, first step of working. Now the second step of working is that we have to shift the constant term to the other side of the equation. Here the constant term is 1 by 7. So we have to shift that constant term to the other side of the equation. So it will become x squared plus 2 by 7x equals 1 by 7. When this term will move to the other, it will become plus 1 by 7. So I hope second step of working is easy for you people now. Now the third step of working. The third step of working is whatsoever is written with x, means the coefficient of x, you have to multiply the coefficient of x by 1 by 2. Whatsoever is the coefficient of x, you have to multiply it by 1 by 2. Let's simplify it. And now you have to add up the square of this term on both sides of the equation. So it will become x squared plus 2 by 7x plus 1 by 7 whole square, and on the other hand side too 1 by 7 plus 1 by 7 whole square. So far we have done 3 steps of working. The very first is that we have to make the coefficient of x squared as 1. The second step is that we have to shift the constant term to the right hand side of the equation. The third step is that you have to multiply the coefficient of x by 1 by 2, and then we have to add up the square of it on both sides. Let's move further to next step of working. The fourth step. If you see the left hand side of the equation, this side, left hand side of the equation, now the square is being completed on the left hand side of the equation. So we can easily close this algebraic identity. So if you see, it is x squared plus 2ab plus b square, and on the right hand side we'll just open up the squares. It will become 1 by 49. So our formula is formed on the left hand side of the equation, so we'll just close it. We'll apply the algebraic identity. This sign will decide that it will be first algebraic identity, and this will be a, means x, and this will be b, means 1 by 7. So we have completed the square, and on the left hand side we'll just take the LCM. There are 2 fractions, we'll make them 1. 49 is the LCM, and here it will become, we'll write the numerator 7 plus 1. Now we are supposed to solve it further. Let it be like this: x plus 1 by 7 whole square, 8 over 49. Now since we have to remove this square, now this is going to be the fourth step of working. After completing the square, we have to remove the square. For removing the square sign, we'll take square root on both sides. So we'll take square root on both sides. This square will get cancelled by the root, and we are left with x plus 1 by 7. And on the right hand side of the equation, it will be square root 8 over 7 and we'll write plus minus with it. Now we just have to solve the equation for the value of x. So x will remain here, and then we'll shift 1 by 7 to the other side of the equation, and it will be minus 1 by 7 plus minus square root 8 by 7. Let's solve it further. Since these are two fractions, we'll make them a single fraction. 7 will be the LCM, so we'll write 1 plus minus square root 8. We can also write square root 8 as 2 square root 2 divided by 7. So this is going to be our solution set. We'll just write the values. We can even write it separately with plus sign, once with the plus sign and then with the negative minus sign, and we can write it collectively as well. I hope you understand the steps of working. The steps of working are not at all difficult. You can revise it. Thank you so very much. Let's solve one more sum. The quadratic equation, which we have to solve by the method of completing square. Let's solve it stepwise. Solution. The first step was to make the coefficient of x square as 1. So here the coefficient of x square is a. So we are going to divide the whole equation by a, so that our coefficient of x square becomes 1. Right? So we'll cancel this. So we are left with x square plus 4 by ax minus 1 equals 0. This was the first step of working of completing square method. Now the second step was to move the constant term to the right hand side of the equation. Here the constant term means the term without the variable x. So we'll shift this 1 to the other side of the equation. It will become x square 4 by ax equals 1. Now what will be the third step of working? Whatsoever was written with x means the coefficient of x. We have to multiply the coefficient of x by 1 by 2. So it will come out to be 2 by a. And then we have to add the square of it on both sides of the equation. So it will become x square plus 4 by ax plus 2 by a whole square of 2 by a equals 1 plus 2 by a whole square. What we have done in the third step, we have multiplied the coefficient of x by 1 by 2, and then we have to add up the square of it on both sides. Now on the left hand side of the equation, our square is being completed, so we have to apply the first or the second algebraic identity depending upon the sign. So we are supposed to apply it, and we have to close the square. So if you see, the first term in the identity is x square, then the 2ab term, let's make it 2 times of a and that of b, so that you see it will again multiply, you can say 4x by a, and this was the last term, square of last term. And on the right hand side it will be 1 plus 4 over a square. So we are supposed to complete the square, and here the first term x, here the second term 2 by a, and this sign decides that it is going to be the first algebraic identity. So we have just closed the square, and on the right hand side we'll just have two fractions. We'll make them a single fraction. So a square is the LCM. So we are going to have as the numerator a square by a square plus 4. In the next step, what we are going to do, we'll have to remove this square. So we'll take square root on both sides. X plus 2 by a whole square equals, and on the right hand side also we have to take the square root. So square will get cancelled by the root, so we are left with x plus 2 by a, and on the right hand side plus minus of a square by 4 divided by a, because it is the property of a radical sign that it is, if it is on complete fraction, then you can even write it separately as like this. So if you take the square root of a square, so it will come out to be as a. So, and in the next step of working, since we have to just find out the value of x, so we'll take this term to the other side. We'll go minus of 2 by a plus minus a square plus 4 divided by a. Since these are two fractions, so we'll make them a single fraction. A is going to be the LCM, and we have to write down the numerator as well, right? So so we got the value of x, so this is going to be the solution set. We can write it once with the plus sign and once with the minus sign, and even we can write it collectively. So this is the solution of the equation of the quadratic equation by completing square method. Hope you understand the sum. Okay, let's do further practice of completing square method. So we are solving quadratic equation by this method. Solving equation means that we have to find out the value of x, and the method given is completing square method. So by now I hope you remember all the steps of working. Steps of working are same, just the equations are different. So let's start. The very first step of working in completing square method is that we have to make the coefficient of x square as 1. Here it is 11. So making it 1, we are going to divide the whole equation by by 11. So that the 11 will get cancelled by 11 and will be left behind with 1. So we are left with x square minus 34 by 11x plus 3 by 11 equals 0. So we are done with first step of working. The second step of working was that we have to shift the constant term to the right hand side. So x square minus 34 by 11x equals, when we'll shift it, it will become minus 3 by 11. So this is the second step of working. First was to make the coefficient of x square as 1. Second was to shift the constant term to the right hand side. Now the third step is that we have to multiply the coefficient of x by 1 by 2. Here it is 34 by 11. So let's solve it. It will get cancelled. We are having 17 by 11. So what was our third step? To multiply the coefficient of x by 1 by 2, and whatsoever we'll get at the end, we have to add up the square of this term on both sides. So it will be, now when we add up the square of it, it will become 17 by 11 whole square equals minus 3 by 11, and we'll add up the square of it, 17 by 11 whole square. Now if you see, in the third step, our terms are completed on the left hand side and we can easily complete the square. Let's make it the second or the first algebraic identity. The first term is of x square minus 2xy hota hai. So let's make it 2 into x into 17 by 11 plus 17 by 11 whole square, and on the right hand side we'll just open up the square. 17 square means 289, and 11 into 11 means 11 square means 121. So if you see, we can easily see that on the left hand side our terms for completion are there, so we can easily close this algebraic identity. This sign will decide that it will be second algebraic identity, and these two are the terms for a and b. So x minus 17 by 11 whole square, and on the right hand side we'll just take the LCM. Since these are two fractions, we'll make them one fraction, 11 and 121. So 121 is the will be the LCM. So 11 times and 11 3 times is 33, and we are going to have 289 over here. Let's simplify it further. So it will become, when you subtract it, it will be 256 over 121. Now in the fourth step of working, we are supposed to remove this square, so we'll take square root on both sides. 256, 121. So we have taken square root on both sides. Square will get cancelled by the root, and we are going to have x minus 17 by 11 equals plus minus 16 by 11. So since we just have to find out the value of x, so we'll shift this term to the other side. So we are going to have x equals 17 by 11 plus minus of 16 by 11. So we'll make it once with the plus sign and then with the minus sign. So we are going to have, these are two fractions. We are going to make them single fraction. 11 is going to be the LCM, 17 plus 16. And we are going to have 13, 3 by 11. And we are going to have 3. And then on the other hand side, 11, 17 minus 16. And we are going to have 1 by 11. So at the end we are going to write down the solution set 3 and 1 by 11. So this is the solution set. So I hope you understand each step of working. Let's solve one more quadratic equation with the help of completing square method. The very first step is to make the coefficient of x square as 1. Here it is L. So to making it 1, for making it 1, we'll divide the whole equation by L. So we'll get cancelled and we are having the coefficient of x square as 1 now. So this was the first step of working, to make the coefficient of x square as 1. Now the second step of working was to take the constant term to the other hand side. Constant term means the term without the variables x, y, z. So we'll have to shift this constant term to the other hand side of the equation. So it will become minus n over L. And the third step of working was to whatsoever is written with x, means the coefficient of x, you have to multiply the coefficient of x by 1 by 2, and then you have to add up the square of it on both sides of the equation. So let's see what it will become. M by 2L whole square. Similarly, on the other hand side, we'll also add up the square of it. Okay, so I hope you remember now the 3 steps of working. The very first is to make the coefficient of x square as 1. The second is to make the constant term to the other hand side. The third is to multiply the coefficient of x by 1 by 2 and then the adding up the square of it on both sides. Let's solve further. On the left hand side of the equation, you see the R square is being completed. And let's see how we are going to make it completed, like x square do 2 times of x, m by 2l, and then m over 2l whole square. And on the right hand side, let's solve it. Let's open up the square. It will become m square and 4l square, right? So our square is being completed here. So we'll just close the algebraic identity. This sign will decide that it will be our first algebraic identity. So the first term and the last term. So we'll have closed the square, and on the right hand side we'll just take the LCM. It will become 4l square minus 4nl plus m square. Now since we have to remove the square, so in the fifth step of working, we'll just take the square root on both sides so that our square will get removed, right? So square will get removed by the radical sign, so we are left with x plus m over 2l equals plus minus of, let's say we can even write it like this, just rearranging the terms, and over 2l, right? Since the radical is on both numerator and denominator, so we can even write it separately. Now since we only need the value of x, so we'll shift this term to the right hand side. So it will become minus m over 2l plus minus m square minus 4nl divided by 2l. So since these are two fractions, so we can make them a single fraction. 2l is going to be the LCM. So we will write just the numerator, and we got the value of x. So we'll write down the solution set. We can write it separately, once with the plus sign and then with the minus sign. And we can write it collectively as well. I hope you understand the steps of working. Okay, let's solve fifth part of question number 3 of exercise 1.1, in which the method mentioned is the completing square method. So the first step of working is to make the coefficient of x squared as 1. Here it is 3, so we'll divide the whole equation by 3 so that the coefficient of x squared will become 1. So it will get cancelled. So we are left with x squared plus 7 by 3x equals 0. And then what was the second step of working? To shift the constant term to the right hand side, since there is no constant term here. So our second step is already done. Now the next step of working is going to be that multiply the coefficient of x by 1 by 2. The coefficient of x here in this case is 7 by 3. So we'll make it 7 by 6. And then we have to add up the square of this term on both sides of the equation. So it will be 7 by 3x plus 7 by 6 whole square, and on the other hand side also will be having 7 by 6 whole square. Now if you see on the left hand side, our square is being completed by 3 terms. We can easily close this algebraic identity. So it will become x square plus 2a plus b and plus b square, and let it be like this. So if you see, we are having the 3 terms completed. We can easily close the square. This sign will decide that it will be first algebraic identity. So this is going to be our square is completed here. So we are having square on both sides. We are supposed to remove the square. So for that, we'll take the square root on both sides. And on the here also we'll be having this. So square will get cancelled by the root. Here also square will get cancelled by the root. So we are left with x plus 7 by 6, and on the other hand also 7 by 6. Since we just need to find out the value of x, so we'll shift this term to the other hand side. So it will become x equals minus 7 by 6 plus minus 7 by 6. So we are going to write it separately so that we can easily find out the values. Once with the plus sign and then with the minus sign too. So these two are same terms with different signs, so that will get cancelled. Here we are going to have the LCM taken, minus 14 by 6. So it will become 2 7 times 14 to 3 times 6. So we got two answers. At the end, we'll just write down the solution set. It will be minus 7 by 3, comma 0, bracket close. So I hope the steps of working are now easy for you. Let's solve one more quadratic equation by completing square method. Let's solve it step 5. The very first step of working was to make the coefficient of x squared as 1. Here it is already 1, so our first step of working is already done. The second step of working was to take the constant term to the right hand side. Here it is minus 195. When you will shift it to the other side, it will become plus 195. The third step of working was to multiply the coefficient of x by 1 by 2. Here it is 2, so when we'll multiply, it will become 1. So, and then you have to add up the square of it on both sides. Let's add up the square of it on both sides. It will become 195 plus like this. If you see, the left hand side of the equation is now the second algebraic identity. So we'll just close the formula. So it will become x minus 1 whole square. And here it will become 195 plus 1, that becomes 196. Now since we have to remove this square, so we'll take the square root on both sides. So here it will become x minus 1 and plus minus 14. So we just need the value of x. We'll just shift this term, that is 1, to the other side. It will become x is equal to 1 plus minus 14. So once you'll write it with the plus sign, and then you'll write it with the minus sign. So we'll have x equal to 15 and x equal to minus 13. So we got two answers. At the end, we have to write down the solution set, which is minus 13, comma 15, bracket close. Let's solve one more sum from the same question, that we are solving the quadratic equation by completing square method. This is going to be the seventh part, which is x square minus x square plus 15 by 2 is equal to 7 by 2x. Usually we are having plus sign with our x square term, so let's make it positive. So it will be like this. Let's shift this term like this, or you can easily write it as x square plus 7 by 2x is equal to 15 by 2. So if you see in the equation, the first step of working was for in completing square method to make the coefficient of x square as 1. It is already 1, right? So first step of working is already done. The second step of working was to shift the constant term to the other hand side. The constant term is already on the right hand side, so it is already done. Now we'll move further to the other steps, which was to multiply the coefficient of x by 1 by 2 and then adding up the square of it on both sides. So we have to add up the square of 7 by 4 on both sides. So it will become x square plus 7 by 2x plus 7 by 4 whole square, and on the right hand side also we'll add up the square of 7 by 4 on both sides. So we have added up the square. If you see on the left hand side, our square is being completed. We can easily close this algebraic identity. It will now become x plus 7 by 4 whole square. And on the right hand side, we'll just open up the squares. It will become 49 by 16. We'll just make these two fractions as one single fraction. It will be 16, and here we'll have 120 plus 49. It will become as like 169 by 16, like x plus 7 by 4 whole square is equal to 169 by 16. So since we have to remove this square, we will take the square root on both sides. It will become x plus 7 by 4 whole square, radical sign, and then square root of 169 by 16. When the square will get cancelled by the root, x plus 7 by 4, and on the right hand side it will become plus minus 13 by 4. So since we just have to find out the value of x, so we'll move 7 by 4 to the other side. It will become x equal to minus 7 by 4 plus minus 13 by 4. So these are two fractions, we'll make them single fraction. So we'll write it once with the plus sign and then with the minus sign. So these are two fractions, we'll make them single fraction. Here it will be 6 by 4 and 3 by 2. So we got one root, one answer, and on the right, and for the other factor, again we are having minus 7 minus 13 become minus 20 by 4, and it will be minus 5. So at the end we have to write down the solution set also. That will be minus 5 comma 3 by 2 bracket close. Hope you understand the steps of working of this completing square method. Let's solve another quadratic equation by completing square method. Let's solve it stepwise. The very first step was to make the coefficient of x square as 1. Here it is already 1. Let's move to the second step now. That was to shift the constant term to the right hand side. So it will become x square plus 17x, and it will become minus 33 by 4. The third step was to multiply the coefficient of x by 1 by 2. Here the coefficient of x is 17, so we'll multiply it by 1 by 2 and we'll add up the square of it on both sides. So our equation will become 17x plus 17 by 2 whole square. Also on the right hand side 33 by 4 plus 17 by 2 whole square. So if you see on the left hand side, the three terms of our squares are complete. We can easily write it like this also in the form of an algebraic identity. So you can easily close it 2x and 17 by 2 and then 17 by 2 whole square, and on the right hand side you see you just open up these squares to 89 by 4. So our square is being completed. Let's go close this algebraic identity. This sign will decide that it will be the first algebraic identity, and these two are the terms of A and B. So, and on the right hand side these are two terms. Let's make them single fraction. So it will be x plus 17 by 2 whole square, and on the right hand side it will become 256 by 4. So we have to remove the square, so we'll take radical, we'll take radical sign. That means we have to take the square root on both sides, 256 by 4, and then square will get cancelled by the radical sign. X plus 17 by 2, here will be plus minus 16 by 2. So since we just need out the value of x, so we'll take this term to the right hand side. So it will become x equals to minus 17 by 2 plus minus 16 by 2, right? So these are two terms, so we can make them a single fraction. So x equals to minus 17 by 2. Once we'll write with the plus sign and then we'll write with the minus sign, so we can easily solve it. So these are two fractions. It will become one single fraction. Here it will become minus 1 by 2. So we get one answer. And for the other value, minus 17 minus 16, the LCM is 2. So we'll just write minus 33 by 2. So at the end we have to write down the solution set too. Let's write down the solution set. Solution set will be minus 1 by 2 comma minus 33 by 2 bracket close. I hope you understand each step of working. Let's solve one more question by completing square method. For having that method to be started, we need the equation in the standard form. So we are supposed to convert this equation into standard form. For converting the equation to standard form, we must have to get rid of these denominators. So we'll multiply the whole equation by LCM so that we can get rid of these denominators. Multiply equation by LCM, and the LCM here in this case is 3x plus 1. So we are going to multiply each term of the equation by this LCM so that our denominators will get removed and we can easily turn our equation into standard quadratic equation, so that after we can apply the method of completing square. So our terms will get cancelled, 3x plus 1 here and also here on the right hand side. So we'll write down the remaining terms. 4 3 times is 12x plus 4. Here we have minus 8. Here we have 3x here plus 5. So let's further simplify it. Minus 4 equals 3x square plus 5. Since we are having a plus sign usually with the square term, so we'll shift all the terms to the right hand side and we will be left behind with 3x square minus 12x plus 5 plus 4. 0 equals 3x square minus 12x plus 9. This equation can be written, it like that, or 3x square minus 12x plus 9. So see, we have converted the given equation into standard quadratic form. Now we are supposed to apply the method of completing square. For that, we are going to have 1 with the coefficient of x square should be 1. So we'll divide the whole equation by 3. This was the very first step of working. So it will be like that. So this term will get cancelled. X square minus 4x plus 3 equals 0. The second step of working was to shift the constant term to the right hand side. So here we have x square minus 4x equals minus 3. The third step was to multiply the coefficient of x by 1 by 2. Here the coefficient of x is 4. So we will multiply the coefficient of x by 1 by 2. We'll get 2. And then we have to add up the square of it on both sides. So let's add up the square of this 2 on both sides of the equation. So we are going to have x square minus 4x plus 4 equal minus 3 plus 4. So if you see on the left hand side of the equation, our formula is completed now, and we have completed the square. We can close the algebraic identity. We can write it like x minus 2 whole square, and here we are going to have 1. Now we have to get rid of the square. For that we have to take the radical sign, means we have to take square root on both sides. Square will get cancelled by the radicals, by its radical sign. So x minus 2 equals to plus minus 1. So we just have to find out the value of x. We don't need 2 here, so we'll move it to the other side. It will become x equals 2 plus minus 1. So we'll write it as 2 plus 1 and 2 minus 1. So we'll be having x equal to 3 and x is equal to 1. So our solution set at the end will be 1, 3 bracket close. So I hope you understand the step of working. Let's solve the last part of this exercise 1.1, question number 3, in which we are solving quadratic equation with the help of completing square method. So you see in this 10th part, our equation is not in standard form. So first we are going to open up the squares. We have to add, subtract the like terms, and we have to convert this equation to standard form so that we can further apply the steps of completing square method. Let's open up the squares. This is the first algebraic identity. It will be a square plus 2ab plus b square. So it will have 4ax plus 4a square, like this. And on the let's write down the remaining terms. On the right hand side also we'll open up the bracket. 7 5 times is 35ax, and it will become 115a square. Let's open up the bracket. It will become 7x square, 28ax, and 28a square plus 3a square. Let's move all these terms to the left hand side so that we can add, subtract the like terms in the next step of working. Right? So let's say which three terms are going to be added up. This is 7x square. This is 7x square. And then we are going to have one term 28x and then 35ax. It comes out to be minus 7ax. And then we are having this term is of a square, a square, a square. When you solve these three terms, we'll get minus 84a square equals 0. So we have converted the given equation into standard quadratic form. Now we can apply the method of completing square. Let's solve it. So the very first step was to make the coefficient of x square as 1. Here it is 7. So we'll divide the whole equation by 7. So that coefficient of x square will become 1. So we have 1 now. Here also it will become this. It is 12 7 times 84 is equal to 0. Now the second step of working was to shift the constant term to the right hand side. It will become x square minus ax equals 12a square. So I hope you remember all the steps of working. Steps of working are same, just the terms and the equations are different. The third step is to multiply the coefficient of x by 1 by 2 and add up the square of it on both sides. Let's add up the square of 1 by 2a, or a by 2, it's the same thing on both sides. Right? On the left hand side, our square is being completed. Let's make, you can even write it like this in the form of the formula 2ab, like that. You see, the equation, the left hand side is being converted into the formula, and on the right hand side you can open up the square. Now let's further close the formula. It will become x minus a by 2 whole square. This sign will decide that it will be of second identity, and on the right hand side let's just make them one single fraction. It becomes 48a square plus a square. X minus a by 2 whole square, it will become 49a square by 4. since we have to get rid of this whole square. So what we'll do, we'll just get rid of the square. So we'll take radical sign, squaring both sides, taking square root on both sides. So square will get cancelled by the root. X minus a by 2 equals 7a by 2, plus minus 7a by 2. Since we don't need the value of a by 2 over here, so we'll move it to the other side. It will become x equal to a by 2 plus minus 7a by 2. So we'll write it once with the plus sign and then with the minus sign, so that we can find out the values. So these are two fractions, we'll make them a single fraction. 8a by 2, it will become 4a. So x is equal to 4a is one answer. And here it is minus 6a and it will equal minus 3a. So x equal to minus 3a is another answer. So at the end, we'll just write down the solution set. So our solution set will be minus 3a, 4a, bracket close. So this is how we are going to apply the method of completing square on our quadratic equation. So I hope you understand each step of working. So if you don't, you can ask me in comment. Thank you so very much. Allah Hafiz.